Hello and welcome back to our second tutorial on MySQL. Um, I believe by now you should be familiar with the workbench after going through the first video. So it's time for us to dive into a connection and begin to create our databases, tables, and then enter data into the databases. All right, so I have one connection here, so I'm going to create a new connection. So I'll simply hit the plus icon here. Then I'll call this connection DBL300. Let me make it DBL300. Okay, so I'll hit OK here. So we have our new connection here. So let's dive into that connection. Normally they will ask you for a password, but what you can do is to save it to Vault after you enter the password for the first time. So that's what I'm going to do. And subsequently, if I'm entering any of these connections, they wouldn't require a password. So for beginners, I mean, it's best to yeah, save your password to Vault. Yeah. Okay, so we are now in the SQL editor, yeah, the workbench editor. All right. And the configuration is already done, so I don't have to do anything about the configuration of the interface. Okay, then in my navigator pane, we have what the Sakila and World databases. These are default databases that are installed during your time of installation. Okay, so let me zoom out the scripts for clarity's sake. Okay, so the first thing we are going to do is to create a database. The first thing we're going to do is to create a database. But even before we create a database, let me lay some background. Yeah, we'll be creating a database for a school in this particular tutorial. And then we need to understand some basics there. We need to know what an entity is. It's very important for you to be able to create your database. You should know what an entity is, and you should know what attributes are. Yeah. So an entity is anything, any object, a person that we are interested in storing information about. That is an entity. So when you go to the school, you can identify so many entities you'll be interested in storing data about. And we can have a student as an example of an entity in a school where we want to store data about the teachers, their courses. We can talk about examinations, hostels, extracurricular activities. Yeah, so all these can be entities. But the reason why we want to identify our entities is that we need to create tables. You know, in relational database, we create tables, and the tables are the repository where the data is stored. So we need to create these tables, and the tables are created based on the entities. Yeah. So in essence, the entities become the tables in your relational database. And the attributes, what are the attributes? The attributes are the features or characteristics of the entities you have identified. Okay, so for instance, if you have identified a student as an entity, the attribute will be the student ID, the student name, age, date of birth, phone number, address, and so on. So these are the attributes of the entity students. Yeah. And in the tables, the attributes also become the columns. Yeah, so the tables look like your normal spreadsheet. So you have rows and columns intersecting each other, and then the columns are going to be the attributes, and the records. Yeah, the rows will be the records. So let's bear that in mind. So in creating the school database, we'll first of all create a database called UPSA. Let's use UPSA as an example here. So we'll say create either database or a schema. So here we'll be using the terms interchangeably. So if you say create database or you say create schema, it means the same thing. Yeah, even though the schema actually refers to the structure of the database. Okay, so we are going to call it UPSA. Okay. Yeah, let me add DB, UPSA database. Okay. That is the name of our database. Normally, we end our SQL commands with a semicolon. Okay, so don't forget that. All right, now we can what execute. So we have what three execution buttons here. But if you want to execute a line, you use the middle execution button. So I'm going to hit that, and then we'll look at the output pane. Okay, so the database has been created successfully. When you look at the output, the time has been given. Yeah. Okay, let's look at our navigator. When you look at the navigator, we don't see any what changes there. We still have what the default databases or schemas. So we'll need to refresh the navigator to be able to see our UPSA DB. Okay, let me refresh that. All right, so you can see that the UPSA DB has appeared. All right, so the next thing we'll do is to activate one of these databases. Currently, we have what three databases there, but none of them is active. You know a database is active if the font is in bold. Okay, let's activate it with this statement. Use UPSA DB. All right, so we'll end it with a semicolon and then let's execute that. Okay, so we can now see that the UPSA DB or database is active, and then they've also displayed a drop down with tables, views, stored procedures, and then functions. Yeah, so don't worry so much about these. They are just inbuilt functions that allow us to create tables, views, stored procedures, and functions. So I'll just close that drop down and then we can move on. Okay, now having our UPSA database active, it is time for us to create tables that will store data in our UPSA DB. So let's save the script. Yeah, we're going to save this script as UPSA DB general or UPSA general. I think I have something like that, so I'll call it UPS general gen. So that is the name of what my script here. Let's create a new script. So we'll use the pick tool here, just right below the file menu. And then we have what a new script. So we are going to name this script as tables, or let's call it profile, because we'll be storing the student profile information. So that will be the first table we'll create, the student profile table. Okay, so to create our table, the general syntax is that you use the create table keyword here. So create table, let's go create table. All right, let me zoom it out a bit. Okay, create table. Now you bring the name of the table you want to create. I want to create a table that will store student personal information. So I can call it student profile. Student profile. All right, then the next thing you do is to add your attributes or columns in the table, and then to do that you put them in in brackets, so they should be enclosed in a bracket. So you can open and close brackets, and then you put your semicolon so that you don't forget. So we'll now enter the brackets and then push it down a bit, and we'll begin to add our attributes or columns for that matter. So the first column we'll add will be the student ID. All right, so let's have student ID, and we'll have to define or declare the data type. All right, so we'll be using the data definition language terminologies to do that. So we'll define the data type. So I will say let's use character here. So as we go along, we'll be learning these data types by using them. That's what I want us to do. Okay. So I'm using a character data type here, and the reason why we use a character data type is that when we have a fixed length data, when we have a fixed length data, we use what a character data type. And also, it shouldn't be what number. It shouldn't be what numbers for arithmetic purposes. Yeah. So if it is numbers for arithmetic purposes, you can use what character. Yeah, but character will accept numbers that are not what going to be used for computations. So you can take note of that. Okay, so the character data type will what work here because the student ID is of fixed length for what all students. You all have what an ID with a size of what 8 digits. So what indicate the size as 8. Okay. Then also in relational database, it is also important for us to ensure that we have what unique records. And to ensure unique records, we use what we call the primary key. So the primary key will be a field that will allow you to uniquely what identify your records. And when you look at all the fields will be what entering for the student. The student ID is one of the fields that will uniquely what identify all students, even better than your names. Because I mean we can't use your names because some people may have the same name. That is possible. Yeah. So we will see the student ID as a unique field, and then we can make it the primary key field. So the primary key field, you can do that by what? Simply adding primary key to that particular line. So we'll say primary key. Okay. So at times, I mean, you're also going to see that they will say primary key and they will add what auto increment. Yeah. So with that, it means the system is going to generate the IDs automatically. But in our case, you have your student IDs already, so we don't have to use auto increment. Yeah, but in a situation where there are no what pre determined what IDs, you can use the system to generate or assign new IDs as you want to enter records into your database. So let me get rid of what the auto increment. Perhaps later on we'll be using it in one of the other tables. All right, so normally we should end our tables with comments. So let's move on to the next one. That will be what student name. Okay, for student name, I'm going to use what variable character data type because your student names are of what different lengths or different sizes. Yeah, so the varchar, which represent variable character, should be the ideal data type here. So let's indicate the size. So the size, you'll be looking at the possible what longest or largest name you can get in the class. So I'm assuming that nobody should have a name that is more than 50 digits. So I'm going to use this the 50 for the size here, and then we can put our comma and move on. So we can also put what the date of birth. So with that one, I'll shorten it and say DOB. Okay, then the data type will be dates, and then we can put a check here. Yeah, so in this particular field, a check will be very important so that we ensure that nobody enters a date that is in the future, because nobody can be born in the future. Yeah, so sometimes you have to put in some checks to ensure accurate data. Yeah, people can play mischief or they can make errors. Yeah, so we'll put a check. So we'll say check, then we'll open a bracket, and then we'll define the criteria. So the criteria is that DOB should be what less than or equal to today's dates. So at least I'm assuming that nobody should be born. Nobody who is already born, yeah, shouldn't have a date of birth that is beyond today. Yeah. So we are going to use the today's date 21st. Okay, 11, and then what am I doing? And today is 22nd, so 22nd. But I should remember to put this in quotes as well. I mean, just the date. Only the date should be in quotes. Okay, so I can close the bracket here, put my comma, and go to the next line. So the next thing we will add will be what the phone yeah, or the phone number. So let's get that. So with the phone number, you can use numeric, you can use integer, um, yeah, you can use numeric, you can use integer, and then you can use character. And I would like to use what character because we are not going to compute our phone numbers. Yeah, and then the phone numbers are always of what the same size. So the Ghanaian phone numbers are 10 digits. So let's use 10 here as the size. So let's go to the next folder. We'll just add address. So with the address, you can use what varchar, or you can use some text. So I'm going to use some text here. But varchar would have even been more appropriate because varchar will allow you to define the size. If you are using text, you don't have to define the size of text. But varchar, let me see, the capacity of what the varchar data type is what is more than what the text data type. Yeah, but the varchar, the advantage is that you can define any size you want to allow. Yeah, but the text you cannot define the size you want to allow. Yeah, but nonetheless, I'll still use text here because it will work as well. And also, I'm using varchar a lot, so I would like to vary that so that you can know that we can use what other data types. Okay, so let me see what else should I add, or let's leave it here for now, and then we can run our table. So at the moment there are no syntax issues, and then let's execute it and see what happens. But you can also see that from line 1 to line 6, they've indicated a line. So that is to tell you that this whole code we are seeing here could have been in one line. The whole command could have been in one line. Okay. All right. Let's execute that. Okay, so I think it is successful. Let me raise it here. So our table has been created successfully. Let's get back to our general script and we can look at the description of the table. So the structure. So when you want to see the structure, you use describe. Okay, describe. You bring the table name, which is student profile. Okay. So that is student profile. Let's execute that and then we'll see the description of our table. So this is our table that we have just created. Okay, so looking at the table, the fields have been indicated here. We have what student ID, student name, date of birth, phone number, and then what address. So at the moment, we don't have gender. We don't have gender. I should add gender. All right, then we have the types. So we have the character, the size is 8, varchar 50 date, and then the character size for the yeah, phone number is also 10, and then we have text. And then when we go to the next column, you can see that for the student ID, yeah, the null is indicated no. It means it cannot take empty records. So that particular field cannot be empty. If you must enter records, then you have to provide value for the student ID. And the reason is that we've made it the primary key. So if you look at the keys, they've indicated that it's our primary key. But the rest of them, we've not indicated yeah, whether they should be so by default, it's going to set them to null. Yeah, but if you don't want it to be null, then you have to indicate not null, yeah, at the end of that particular field, and then they will also be mandatory. So we only have the student ID field here, that is mandatory. The rest are optional, so you can choose to provide data values or not. Okay, so that is the structure of the table. All right, so after creating our table, we just remember that we should have added gender. We didn't add gender. We should have added gender. So there are two ways to do this. The first, you can delete, or to delete the table. We say you can drop the table and then make the modification and get back to run the table again. But you can also alter the table. So you can alter the table outside with another command. So here we are going to learn to use the alter command here. So I'll say alter. Let's say alter. Okay, then we'll say alter, then you bring the name of the table. So alter student profile. Okay, alter student profile. Okay, we should be careful about the spelling. I've gotten the spelling wrong here. Yeah. So alter student profile, then we'll say yeah, add. So we are adding a new column. So add gender. So you add gender. Then you define the data type. So the gender data type will use enumerate, because there are a list of options we can use. So I'll call this one yeah, male and then female, or usually we bring the females first. So let's say females. Okay, and then we'll bring the males as well. Okay, so let's close that, and then so alter student profile, add gender, then enum. Okay, so that is it. We can put our semicolon here, and then we can run the command. So there is an issue there. Okay, so alter student profile. Okay, the name is right. Then let's see. Let me click here and see what the error is about. Okay, so alter the table. So we are altering the table here. Then add gender. The data type is enum. Okay, so I think we have to add alter table. So the word table should come before the table name. So you can see that it's okay now. So alter table student profile, add gender. Gender is a column we are adding, and the data type is enum, and then we bring the list there. So let's execute that, and then we can proceed. Okay, so there is, oh, I have selected, you see, I highlighted some other things, so that was what created the error. Let's execute it once more. Okay, so all right, so it's going to work all right now. So we are done with the alteration of the table. So now we can go and look at um, the structure of the table once more. Let's go to the general script, and then we rerun our description. Okay, so this time you can see that we have a new column added that is called gender, and then the enum data type is also indicated. All right, so let's say we want to add one more folder we've forgotten about, so I can add that below here. Oh, what is happening? My mouse is beginning to misbehave. All right, so let's use alter table. Then we'll bring the name of the table, student profile. Okay, then we'll add, what can we add here? We can add program, or yeah, we can add program. So let's add a program here. Okay, so the program, we're going to use varchar for the data type. Then the size for the data, we'll use 50, or let's make it 60 this time. Okay, and then we'll put our semicolon. All right, let's execute it and we can move on. All right, so that is also done successfully. Okay. All right, now our table is okay. Um, we can go to describe the table once more, and then we'll look at the outcome. So you can see that a new column or a new field called what program has been added to our database table structure. All right. So I'm going to create a second table. The second table will be for what the exam. Let's create the exam table. To create the exam table, let's add a new script. Okay, I'm having issues with my mouse. Okay, so I'm going to end it here, and then I'll do a different video to create another table.